Hello guys, myself Shishir. Today we are going to study mechanical engineering first semester, second module. So here are some topics which we are going to study. What role does automobile play in our daily life? How do they work? What are IC engines? Classifications of IC engines, working principle of IC engines, components of IC engines, advancement, and next steps to be taken. First topic: the automobile industry comprises a wide range in our life of companies and organizations in the design, development, manufacturing, marketing, selling, repairing, and modification of motor vehicles. It is one of the most largest industries by revenue. Basically, mechanical engineering helps out more in motor vehicles, development, designing, manufacturing things, selling, repairing, etc. How do they work? Especially motor vehicles. Motor vehicles work upon the principle of IC engines. IC engines means internal combustion engines. An internal combustion engine is a heat engine in which the combustion of a fuel occurs with an oxidizer in air combustion chamber. That is an integral part of the working fluid flow circuit. In an internal combustion engine, the expansion of the high temperature and pressure gases produced by combustion applies direct force to some of the components of engine. Uh, the force is typically applied to the pistons. Basically, internal combustion engine helps works on the principle of combustion, where fuel burns inside the IC engines to turn into mechanical energy. There are two types of IC engines. One is four-stroke engine and two-stroke engine. In four-stroke engine, we can see two different types of IC engines. One is diesel and petrol. Working of four-stroke engine petrol. First stroke is intake stroke. In a four-stroke cycle petrol engine, during suction engine petrol intake stroke. In a four-stroke cycle petrol engine during suction stroke, the air fuel mixture is introduced to the combustion chamber, whereas in a four-stroke cycle diesel engine during suction stroke, only pure engine is drawn by the piston. The piston moves from top dead center to bottom dead center. Top dead center is fastest position of position. As the position moves towards bottom dead center, it creates a low pressure area in the cycle. The intake valve remains open up to a few degrees of crankshaft rotation after BDC. And as the intake valve closes, it seals the air-fuel mixture in the cylinder. During the suction, intake valve remains open. The outlet valve remains closed and then crankshaft rotates to 108. During suction is compressed inside the cylinder. During the compression stroke, the position moves from bottom dead center to top dead center to compress the air-fuel mixture. The piston moves forward with the help of flywheel momentum on compressing the air-fuel mixture. More energy is released on charge ignition. The charge is the volume of compact air-fuel mixture sealed in the combustion chamber, ready for ignition. During compression, both the inlet and outlet valve remain closed, and the crankshaft rotates 108 degrees more than now. The total rotation of crankshaft is 360 degrees. Combustion stroke. It is also called as power stroke. After compression, the crankshaft completes one full rotation, and its second rotation begins. When the compressed air fuel mixture is kindled with the help of spark plug, the power stroke occurs. Combustion is rapidly processed, and the oxidized chemical reaction releases heat energy. The hot expanding gases force the piston away from the head of the cylinder. During combustion, the inlet and outlet valves remain closed and the crankshaft rotates 108 degrees more. Now the total rotation of crankshaft is 540 degrees. During the power stroke, as the piston reaches the bottom dead center, the cylinder is filled with exhaust gases and combustion is completed. Now next stroke is exhaust stroke. During the exhaust stroke, the exhaust valve opens and the inertia of flywheel and other moving parts pushes the piston back to top dead center and allows the exhaust gas through the open valve. The position of piston is at top dead center. So at the end of the exhaust stroke, one operating cycle of engine has been completed. During exhaust, inlet valve remains closed, the outlet valve remains open, and the crankshaft rotates 108 degrees. Now the total rotation of crankshaft is 720 degrees. This is all you have to explain in writing four-stroke petrol engine. Four-stroke diesel engine. First stroke is intake stroke. Intake stroke occurs when the air fuel mixture is introduced to the combustion chamber. In this stroke, the piston moves to top dead center to bottom dead center. The movement of piston towards the bottom dead center creates a low pressure area in the cylinder. The inlet valve remains to open a few degrees of crankshaft rotation after bottom dead center. The intake valve then closes and the air fuel mixture is sealed in this cylinder. Next stroke is compression stroke. In compression stroke, the trapped air fuel is compressed inside the cylinder during the stroke. Piston moves from bottom dead center to top dead center, compressing the air fuel mixture. The moment of flywheel helps the position move forward. Compressing the air fuel mixture allows more energy to be released when the charge is ignited. The charge is the volume compressed air fuel mixture trapped inside the combustion chamber, ready for ignition. The inlet and outlet valve must be closed to ensure that cylinder is sealed, resulting in compression. Next stroke is combustion stroke. The second rotation of crankshaft begin when it completes a full rotation during the compression stroke. The power stroke occurs when the compression air fuel mixture is ignited with the help of spark plug. Ignition or combustion stroke is rapid, oxidizing chemical reaction in which a fuel chemically combusts with the oxygen in atmosphere and releases energy in form of heat. The hot expanding gases forces piston head away from the cylinder head. Exhaust stroke. As the piston reaches to bottom dead center during the power stroke, combustion is complete and the cylinder is filled with exhaust gases. The exhaust valve opened during this stroke, and the inertia of flywheel and other moving parts push the piston back to top dead center, forcing the exhaust gases through the open exhaust valve at the end stroke. The piston is at top dead center and operating cycle has been completed. This is the diagram for a four-stroke engine. You have to draw this. Now let's go to two-stroke engine cycle. There are only as it means two-stroke. There are only two steps in this: downstroke and upstroke. Let's study downstroke first. The position moves from top dead center to bottom dead center, letting the fresh air enter the combustion chamber. The fresh fuel get mixed into the combustion chamber through the crankcase. In this stroke, the crankshaft makes rotation of 108 degrees. This is the diagram you have to draw for the two-stroke engine. Upstroke. The position is pushed from bottom dead center to top dead center. As a result, the fuel air mixture gets compressed and the spark plug ignites the mixture. The mixture expands and the piston is pushed down. The inlet part is opened during the upstroke. While the inlet port is opened, the mixture gets stuck in the crankshaft. When the mixture is pushed up into the combustion chamber during the previous upstroke, a partial vacuum is created as no mixture is left behind in the crankcase. This crankcase until the position goes up to top dead center. In this stroke, the crankshaft makes the rotation of 108 degrees. From the second downstroke onwards, the exhaust gases get expelled out from one side while a fresh mixture enters into the combustion chamber, simulating due to partial vacuum created in the combustion chamber after removal of exhaust gases. This is the beauty of engine. The exhaust gases are expelled from second downstroke onwards from one side while stimulating a fresh mixture of air and fuel is injected into the combustion chamber due to partial vacuum created in the combustion chamber after removal of exhaust gases. This is how you have to write when they give explain or define two-stroke engine. Applications of two-stroke engine. Two-stroke engines are preferred when mechanical simplicity, lightweight and high power to weight ratio are design priorities. They are lubricated by traditional methods of mixing oil into the fuel. They can be worked within any orientations as they do not have any reservoir depends on gravity. They make them self-desirable for their use in handling tools such as chainsaws, etc. Two-stroke engines are found in small scale applications such as motorcycles, dirt bikes, mopeds, etc. Comparison of two-stroke and four-stroke engine. This might come in examination. Two-stroke engine, it has one resolution of crankshaft during one power stroke. Four-stroke engine has two revolutions of crankshaft during one power stroke. It generates high torque, it generates less torque. It uses a port of fuel outlets and inlet. It uses valves for the fuel outlet and inlet. It has larger ratio in terms of power and weight. This engine results in higher thermal efficiency. This has lesser ratio in terms of weight. Whereas two-stroke requires more lubricant oil, such as some oil burners with the fuel. Four-stroke engine is generally more smoky and shows more efficiency. Where comparison of two-stroke and four-stroke is over. Let's go to the next difference between petrol and diesel engine. Four-stroke engine draws a mixture of petrol and air during the suction stroke using carburetor. Whereas diesel engine draws air during suction stroke only. Petrol engine, the carburetor is employed to mix air and petrol in the required proportion and to supply it to the engine during suction stroke. The injectors in diesel engine injectors is employed to inject the fuel at the end of the compression stroke. Comparison ratio of range from 7:1 to 12:1. Comparison of ratio of power and weight is 18:1 to 20:1 in diesel engine. In petrol engine, the charges is ignited with the help of spark plug. This helps of ignition is called as spark ignition. In diesel engine, this is accomplished by the compression of air, which will have been heated due to the high compression ratio to the temperature higher than the ignition temperature of the diesel. We'll go to next slide. Future mobility in vehicles, whereas hybrid, EV and high tech. What is hybrid? Let's explain hybrid. A hybrid vehicle is one that uses two or more distinct types of power, such as submarines that uses diesel when surfaced and batteries when submerged. And other means to store energy includes pressurized fluid in hydraulics hybrid. Whereas in hybrid vehicles, there are both electric powered motors and oil powered motors. Hybrid are designed to switch from one power source to other, maximizing both fuel efficiency and energy efficiency. In hybrid electric vehicles, for instance, the electric motor is more efficient at producing torque and turning the power wheel, While the combustion engine is better for maintaining the high speeds, improving efficiency, lower emissions, and reducing running costs relative to non-hybrid vehicles are three primary benefits of hybridization. Now we'll go to components of hybrid gasoline engines. Hybrid vehicle still has gasoline engines. This remains to be main power source of the vehicle. Electric motor. This is the future. This is the future that makes the hybrid vehicles particularly special. Next, fuel tank. We will still have a fuel tank because we have a gasoline engine. Due to this advanced technology in hybrid cars, the fuel won't need to be used as much. As much we will have to be better fuel. As much we will have better fuel efficiency and produce forever like emissions as a result. Transmission. Most hybrid vehicles will still have a transmission that we could find in regular gasoline cars. Batteries for electric motors. Batteries are the power electric motors such electric motor of hybrid cars. The batteries can actually take power back from the electric motor too. So it's, this is one way the lifespan can be preserved. It cannot be charged for every single time. Generator. If you have a series of hybrid cars, they have a generator which gets powered by gasoline engines. The generators can then generate power for electric vehicles and help recharge the batteries. It is basically a way of converting gasoline into the electrical energy for motor and batteries. Next, we'll go to EV. Electrical road vehicles include electrical passenger cars, etc., buses, electrical bus, electrical trucks, etc., such as electrical buggy, etc. Basically, it uses motor and electricity to run itself. Together with other emerging automobile technologies such as autonomous driving, connected vehicles, and the shared mobility, EVs from future version of transport is called as connected autonomous and shared and electric mobility. We go to high tech. Autonomous car Autonomous car are such. Now let's move on to high-tech cars, high-tech automobiles. Autonomous cars are such instinct to vision of the future of holograms and space travel. This is the birth of science fiction. The automobile has been seen as the final future of technologies and invention. However, when we look around at our cities today, cars can often seem stuck in the past, where high-tech cars uses of autonomous driving, connected vehicles, and shared mobility also, same as EV. Where high-tech cars are more advanced, can drive itself using AI, and more high-tech things. Difference between hybrid and EV. This may come in your examinations. EV, they are they are so they are powered by electric motors and rely on electric stored batteries in batteries or other energy sources system. Where hybrid combines internal combustion engine and with electric motors, they produce zero emission. They produce fewer emission compared to the traditional vehicles. They need to be plugged into an external power source for recharging. Do not require any external recharging. They determine by capacity of their battery packs. They don't require any external charging. Now these are some questions um, where it might come to your examination. Explain the working of four-stroke petrol engine with PV diagram, where you have to draw the PV diagram there and explain the four-stroke engine as shown in the before slides. Working of diesel engine, four-stroke diesel engine with the diagram. Again, you have to draw the PV diagram and as explained in the earlier slide. List component of IC engines. Some components of IC engines you have to list. Define EV and high tech, not high tech cars, so hybrid cars. Difference between petrol and diesel engine. These are some important questions. This is my end of the